If you really like this tutorial and want to learn more, then please check out our Django ORM Mastery course on Udemy. The link to the course, which will always provide the best price, can be found in the video description. Hello and welcome to the ORM Mastery course. This tutorial is part of a bigger course which you can access via the YouTube edition playlist link, which you'll find in the video description. In this tutorial, we introduce Django Signals. Understanding Django Signals is a fairly straightforward process. The art here is to understand why and when to use signals, and that is something that we're going to explore later on in this tutorial. Let's start with some terminology. So events are actions or occurrences that can happen within our system that we are developing. So let's keep this in the context of databases. So an action or an event which might occur would be that we would save data to a database, or we would delete data from the database. Now, there will be occasions where you would like to perform additional actions based upon an action. So in this case, if we take this scenario here, imagine we have a table, a user table and a profile table. There's a one-to-one relationship. If we were to save data into the user table, we may want to perform an additional task of then saving the profile information about that particular user in the profile table. A common approach here in Django is that potentially we could override the save function. Whenever we save a new user, we could expand that function to then additionally save the data inside the profile table. Overriding this save function is just one approach that we could take in order to perform additional operations when an event occurs. In this case, we save data in the user table. Django includes a feature, a signal dispatcher, which can send notifications about events as they occur. These notifications or signals, they can be received, and on receiving these notifications, additional functions can be initiated, thus performing additional operations. Let's go back to our example here, but this time I've separated our two models inside of two Django apps. So we have the account app and we have the profile app on the left-hand side. So let's go through the same example again. We want to add a new user. So we go ahead and add a new user and we run the save function. But this time we utilize Django Signals, and that's going to send a signal to our profile app, and that's going to then run a function. And that function is going to perform the operation of then extracting that data about the user that's just been saved and save that information into the profile model, which is inside the profile app. By using these signals here, what we've done is we've taken the logic out of for example, the account area, and we've made it so all the information or all the logic that's required to actually perform operations that's based upon this app here is now stored inside of this profile app. By using signals, we can send messages across to additional apps, or it doesn't have to be additional apps, it can be within the same app. This is just an example here. We can send signals or messages about actions, events that's taken place, and we can perform these additional functions in additional apps. Now, if my explanation didn't quite make sense or didn't quite hit the mark with you, it'd be well worth now reading through the Django Signals documentation. It's a fairly short page to read through, and it can be useful to just establish what it is that I've just explained. Now, if we go into the signals documentation here, we find that there is a set of built-in signals, and that's going to be the main focus of this section. So Django has pre-built-in signals that we can utilize to send notifications. And here we're focusing on model signals. You can see here there is a signal for the save and delete, for example. So we can ask Django to send signals about when data is saved to a model or when data is deleted from a model. Besides the save and delete signals, you can see that there are other signals here, and we will discuss that later on in this section of the course. You can see initially that there is a signal for pre-save and post-save. So we can perform or have signals sent before the data is saved and after the data is saved, because we may want to perform additional actions before or after data is saved, or before or after data is deleted. One of the first questions that I ask myself when presented with new technologies or new features is to try and answer, what problem does this solve? Now, to answer or understand why or when to use signals, I draw your attention to the observer pattern. In software engineering, a design pattern is a general, repeatable solution to a common occurring problem in software design. The observer pattern is a behavioral design pattern that will let us define a subscription mechanism to notify multiple objects about any events that happen to the object. Now, let's just put that into the context of what we've been talking about so far. So the observer pattern allows us to create a subscription. So here what we have is the account app here again. So let's imagine we have this user model here. Now, what we've done is we've created a new profile app, and we have a profile model here, profile table. Now, what we've done first is we've created a new function inside the profile app, and then we create or register that function to the signal that's attached to the user model here. So now what we have is this registration, this subscription from our function inside of our profile app to the signal here, for example, in the account app. So now we have that subscription. Anytime an event occurs on the user model, let's say the save event occurs or the save action occurs on the user, that signal will be sent out, the fact that data has been saved in the user table, to any of these subscriptions, anyone that's registered to that particular signal. And therefore that signal then is sent, and the function that's registered to that signal will then be fired off. So the problem that the observer pattern is trying to resolve is that you may have a situation within your application where you want to inform multiple objects about any events that happen to the object. So take, for example, the example that we've been showing so far. Whenever we save data into the user model, for example, or delete, whatever we set up, of course, we want to send messages to multiple places to inform them that the save or delete operation has taken place. So just loosely speaking, here, for example, we have a Django application which has 3 apps. We have the account app, statistics app, and profile app. This is all hypothetical, but let's imagine that we had a need for us to store information whenever a new user has been saved. So a new user has been saved. We then create a subscription signal so that the statistics app and the profile app is then registered to a signal that then is sent out when the user is saved. And the signal is passed over to these apps. And then within these apps, there is a function that is fired off whenever a new user, whenever the signal is sent across to these apps. So let's take a step back here. Let's imagine we didn't have signals and we wanted to implement this feature so that whenever we saved a new user, we also wanted to update a table or information inside the profile and statistics app here. Okay, so what we would do here probably is within the account app, we would then override the save function within inside of the account app here, so that whenever we saved information about the user, we would also grab the statistics model and the profile model and go ahead and save the data in those tables or models too. Now, the problem here is that all this code would be within the accounts app. Now, that isn't necessarily a problem. However, if we were to try and build applications that were loosely coupled, so for example, if we wanted to build a statistic app, which we wanted to use on multiple applications, for example, then this approach might not necessarily be the best approach, because in order for the statistics app to work correctly, we're relying on the account app to do some of the logic that the statistic app relies on. And that's obviously saving data into the statistics app. So the account app wouldn't work correctly unless the statistic app exists. So let's imagine we built a new Django application. We split our application into smaller apps, and then we go ahead and build our applications independently. And what we find is, because we haven't planned it correctly, what we find is that all these different apps that we've generated within our Django application, they're all very much cross-application dependent, in that, for example, app 1 relies on parts of app 2, and app 2 relies on part of app 1, and so on. You can see these lines here represent where there are dependencies between different apps. Having such a tight cross-application dependency, this can cause problems when developing applications, when testing the application, because apps are very much tightly dependent upon other apps to work correctly, for example. When building a Django application, we might consider at the design phase thinking about the cross-application dependencies and trying to reduce the dependencies and making it such that applications can be developed more individually without the need or lowering the amount of dependencies that it's required for the application, the individual application, to work correctly. And this is where Django Signals can help us achieve that design principle. Let's go back to this example here that we saw earlier. Here we have two apps. Now, it could be two apps. There could be multiple apps here on the left-hand side. So here what we have is two apps. So instead of taking the approach whereby we hard code and override the save function, and all that code is in the user table, and here we're creating a dependencies because in the user table, we're saying, okay, we're going to need the profile model and so on, therefore creating that connection between the two apps here. Here we're using signals. We create the signal, and when we're ready, we create a new app and we register or create a subscription to that signal in the account app. So whenever the action, or whenever that event takes place, the signal is sent across, and then the profile app can then perform the additional function. So to summarize, Django provides us signals, which allows us to send notifications to other parts of our application. We might consider utilizing signals when we have the need for us to send notifications to multiple objects regarding one particular object, in this case, one model. Whether we want to save or whether we want to delete to this model here, we want to send that information out to multiple different apps or different parts of the application. We might also consider utilizing signals where we want to loosen any tight cross-application dependencies, where we want to try and avoid any circular dependencies. That's where a relationship between two or more application modules or apps are codependent. So here, app 1 is dependent on app 2, and app 2 is dependent on app 1. And that's ideally something that we want to try and avoid. So utilizing signals here, we can avoid that codependency. And by having app 1 send out signals, it means it's no longer dependent upon app 2, for example.